For today's lesson, we're going to be working on ratios and proportions. So a ratio, the relationship between the whole numbers. You might have used ratio when you're cooking or um, measuring things. So a ratio looks something like a whole number over a whole number. It could be written as a fraction, be written like this, or like this. Basically, like if you're thinking about cups of rice to water, this would say you need 2 cups of rice for every 3 cups of water. Whole numbers are positive numbers with no fractions or decimals. So those are the numbers we count by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then a proportion is when you take two ratios and make them equal to each other. So like 2/3 is equal to 4/6. Those are both equivalent fractions and they're equal to each other. There's some property about ratios that we need to know. The first one is if we look at going from the numerator to the denominator on both of these sides. We're going 2 to 3. What we would do there is multiply 2 times 1 and 1/3, or 1 and 1/2, and we would get 3. So going down, let's do that in red just to kind of match it up. So 2 times 1 and 1/2 equals 3. So that's, you multiply the top two by 1 and 1/2, you get the bottom. For blue, if you take 8 and multiply it by that same 1 and 1/2, that would equal 12. So for proportions, which remember is when you've got one fraction equals another fraction, there's this theorem that you multiply the top by the same numbers to then get the bottom. Next one is multiplying straight across. So on this one, we can multiply the top by 4. And the bottom, we would also multiply by 4 to keep those equal to each other. That would be our second example of a truth about proportions. First one, remember, is we multiply the top to get the bottom. Same thing, you multiply the bottom to get the top, and it's the same factor on both the left and the right. Here, it's top and bottom. You multiply the top 2 to get 8, bottom 3 by 4 to get 12. The last one here that we'll talk about is diagonally. So if you multiply the 2 by the 12, 2 times 12 equals 24. If you multiply the 3 by the 8, you also get 24. So we use all these different equivalencies to help us be able to solve proportions when there's a variable put inside them. This example here, you'll often hear it referred to as cross multiplying. It's the same thing as multiplying both sides by the denominator of the fraction to then cancel it out. So first one here, the ratio of blue cars to red cars is 2 to 5. So it's written like this. We could also write it as 2 to 5 or 2 over 5. There are 30 red cars in the parking lot. How many cars are blue? So for this fraction, we're doing, it says blue cars to red cars. So that's going to be blue over red, which means blue over red. Now, this first one is our ratio that we're going to use, the 2 to 5. The second one is using the total number of cars that we know are there. So our ratio is 2 blue to 5 red. And then we know that there are 30 red cars overall. So we're trying to solve for how many blue cars there are. There's multiple ways we could do this. Probably the easiest way is look at how do we get from 5 to 30? Well, we would multiply by 6. So that means we'd multiply the top by 6 as well, because whatever you multiply the bottom by, you multiply the top by. We get x equals 12. 12 blue cars. Don't forget your units. Other way we could have done that, we could have done cross multiplication. So we'd have 2 over 5 equals x over 30. Cross multiply, so you get 2 times 30 equals 5 times x. So that's 60 equals 5x. Divide both sides by 5, x equals 12. The ratio of cloudy days to sunny days was 3 to 5. if there are 18 cloudy days, how many sunny days are there? So we're going to do, it's cloudy days to sunny days. That means this is cloudy, this is sunny. So we'll have cloud over sun equals cloud over sun. This first one will be our ratio that we're given. The second one is using the actual amount or total that we're given the problem. So it's 3 to 5 equals, and we're told that there are 18 cloudy days. So how many sunny days are there? Now, again, you can use any way you want to solve this. This one seems like it's going to be easiest again to just multiply straight across. 3 times 6 gets me 18. So then we'd multiply the bottom by 6 as well, which means x equals 30. If you cross multiplied, 3 over 5 equals 18 over x. Cross multiply, you get 3x equals 90. Divide both sides by 3, x equals 30 sunny days. This time they don't give us a word problem, but it's just the same thing. What I know, this is 5 doesn't go into 11 nicely, so that strategy here will not work well. It can still work, you're just going to have to deal with messy numbers. So on something like this, I'm going to cross multiply. So I get 2 times 11 equals 5 times x. 22 equals 5x. Divide both sides by 5. X equals 22 over 5. Remember, always reduce your fractions if you can. Here, 22 and 5 don't share a factor, so it can't reduce, or just have 22 fifths. I also don't see an easy number from 3 to 17, so we're going to cross multiply again. So we'll have 120 equals 17a. Divide both sides by 17. We get a equals 120 over 17.